over it. So find the missing side of each triangle. Round your answers to the nearest tenth if necessary. So it is a right triangle. So all we're going to use to solve this is a squared plus b squared equals c squared. Okay, so we're just going to use the Pythagorean theorem to solve for the missing side. So I've got x squared is going to equal 12 squared plus 5 squared, or x squared equals 144 plus 25. X squared is going to equal 169. I don't want x squared, I want x, so I'm going to square root it. And if I square root one side, I have to square root the other. And that gives me x equals 13 inches. I'm going to do the same thing for number 2. So I've got x squared equals 9 squared plus 12 squared. So x squared is going to equal 81 plus 144. So x squared is going to equal 225, I think, this time. So get x by itself, I want to square root it. Square root one side, I have to square root the other side. So x is going to equal 15 centimeters. Yeah. Okay, so 3 and 4 changed just slightly. They're still right triangles. I'm still going to find the missing side, except this time it said leave my answer in simplest radical form, which means if I have a root and it's not a perfect square root, I need to just leave it in simplified form, and that's it. So I'm going to do the same thing. So I've got x squared plus square root of 13 squared equals 4 squared. Remember the hypotenuse is the one that's by itself. It's the two sides squared added together equals the hypotenuse squared. So then I've got x squared plus 13 equals 16. Subtract 13. X squared equals 3. Square root. X equals the square root of 3 inches. Oh, no, not inches, sorry. That would be centimeters. Wow, okay, centimeters. And then the last one, my hypotenuse is x, so I've got x squared equals 14 squared plus the square root of 37 squared. So x squared is going to equal 196 plus 37. X squared is going to equal 233. Square root. X equals the square root of 233. I couldn't find anything that 233 went into 233, so there we go. 233, square root of 233 yards. Done. Okay, we are going to talk about that again today, but we are starting our, as I go back up to the top, I should have maybe put the warm up at the top, but that's okay. We're starting our right triangle trigonometry unit. We're starting our trigonometry unit, and our first lesson in there is right triangle trig. Now, I'm going to say this knowing what happened last quarter, and so I'm going to put a caveat on it. You should have learned this last year, okay? I know that this was at the end, that you were being taught this at the end of the year last year, so you may not have, some of you may have learned it, some of you may not have learned the trig, okay? So if you are not understanding what we're doing, make sure that you're asking questions, because this is something that, this is a huge unit. So I need you guys to make sure that you're asking questions on this basic trig part that we're going to go over now. This is just this first unit is just a review of trig that you were supposed to have learned last year. and knowing what happened last quarter, and how some people said they learned it, some people said they didn't. So I'm prepared, a little more prepared for this quarter. So if you guys did not learn it, or didn't learn it very well, or it wasn't taught very well, just make sure you're asking. And in tomorrow's lesson that I post up, so we're going to do this lesson, right? And then we're going to have a review on it tomorrow. But in tomorrow's lesson, I have, 5 or 6 different little videos of me going over how to do each section individually. So if you don't have to watch the whole recording of this or fast forward and try and find it, it's just already in there. Tomorrow's lesson already, each little piece is already in there. I think that might make it a little easier for you guys. I'm not sure. But on helping you find help. But for Trig and basic Trig, there's tons and tons of videos out there on YouTube. So if what I'm doing and what we're doing is not helping, and you don't feel comfortable asking a question for whatever reason it is, there's other places to get help with this. And there's tons of it out there, okay? So we're going to go ahead and start. So this should be a review. I'm not going to say it is, but it should be. So we have a right triangle, right? And the hardest thing about the Trig, I think, and I honestly think the hardest thing about this is deciding which side is the opposite and which side is the adjacent. We're pretty good with what side is hypotenuse because of a squared plus b squared equals c squared. The hypotenuse is always the longest side, and another way I kind of think about it is the one pointing opposite my right angle, right? So it's the side opposite my right angle. So that's always my hypotenuse. It's knowing which side is opposite and which one's adjacent. And in doing that, I need to know which angle I'm looking at. So obviously I'm looking at I say obviously, that may not be obvious. So how do I know that this is the angle I'm looking at? Well, they call it theta. So in Trig, most of the time we're going to use a Greek letter named theta to talk about my angles. It's theta. It's a Greek letter. It's like an 8. It's like a 0 with a dash through it. So it's the Greek letter theta. And that's what we use really to talk about angles. And we use right here. So it says this angle, theta, is theta degrees, okay? So we're talking about this angle. So if I'm talking about this angle, you can see opposite this angle is this side. That is the side opposite. What the word opposite means, opposite. So it's opposite the angle that I'm talking about. Adjacent, just like in English, adjacent means next to. Well, it's next to the angle that I'm talking about. It actually makes the angle with the hypotenuse. So adjacent is part of my angle that I'm looking at. So if you kind of want to think of it that way, it kind of helps a little bit, I think. Just a little thing there. So there's three basic trig functions we're going to look at. The first is sine. Sine is opposite over hypotenuse, okay? And it says sine of theta. S-I-N, it's abbreviated sin. It's said sine of theta. The second one is cosine of theta, is adjacent over hypotenuse, and it's abbreviated COS, cos. And the third one is tangent, which is opposite over adjacent, and it's abbreviated tan. Okay, is there any questions so far? Or are you guys remembering a little bit about this? And then there's the pneumatic way we kind of remember it. I don't know. It's called SOHCAHTOA, and it's just a way to remember the ratios. And I have it written down below too, but SO is short for sine, is opposite over hypotenuse. And CA is short for cosine, is adjacent over hypotenuse. And if you look, it's just the beginning of each one. Sine is opposite over hypotenuse. Ca is cosine, is adjacent over hypotenuse. And TOA, tangent, is opposite over adjacent. So if you can remember SOHCAHTOA, it's just a little way to help you remember the ratio functions. So I hope that helped a little bit. I don't know if it did. Some of you probably have heard it before. I don't know. So okay, so let's go back down here. And then the Pythagorean theorem, we did it already, but we use Pythagorean theorem in trig a lot. In a right triangle, the sum of the squares of the two legs equals the square of the hypotenuse, right? A squared plus B squared equals C squared. So basically in this lesson, we're going to use what's in these two boxes here. The Pythagorean theorem and our trig functions. Over and over and over again. So is there any questions on our trig functions right now? Oh, Chris Cortez. Okay. All right, so we're going to go ahead and see what the first problem says here. Oh, I guess we're not. We're going to go to the next page and see what the first problem says. So I know that if you have the packet, it's because I added the warm-ups in, so it's a little off. But this part is on the first page. So it says, find x in the following triangles. So in this case, x here is my angle. They called it x. Okay, and they give me these ratios. So right now, A is for adjacent. So my adjacent side equals 5, and my opposite side equals 6. So if I want to find x, I need to use my trig functions. And I'm going to write SOHCAHTOA. I need to decide which of those functions I can use to find out what x is. Well, they give me the opposite and the adjacent, so I need to look and see which one of those gives me opposite and adjacent in there, which happens to be this one right here, right? O and A is in that one, both together, opposite and adjacent. So that means I'm going to use tangent. So for one, I'm going to say tangent of x equals opposite, which is 6, over adjacent, which is 5. So that doesn't tell me what x equals. That tells me what tangent of x equals. I still need to solve for x. Okay, so the question is, how do I get rid of tangent? Does anybody remember from last year? And I'm just going to rewrite this a little further away, sorry. 6 over 5. Does anyone from last year remember how to undo tangent? So I want to undo it, kind of like if it was a multiplication, I would divide. If it was an add problem, I would subtract, right? What undoes tangent is the question. I can't divide by tangent because tangent needs to have a number with it to actually be able to divide by something. It's a whole expression. It has tangent of some number. So if I don't have that number, I can't just divide by tangent. So I need to undo tangent to get x by itself. Yes, Paige, good. It's called tangent. It's called the inverse of tangent. So I'm going to take the inverse of it. I'm going to write this in a different color. The inverse, and all it is, it looks like this. It's just tan with the little -1. Inverse of tangent. So if I do it on one side, I have to do it on the other side. So inverse of tangent undoes tangent. That means those two are going to go away. Kind of like a square undoes a square root, and the square root goes away. My tangent is going to go away on this side, and I get left with x. Now the problem becomes putting it into my calculator. So I should have had my calculator up and ready. I am so sorry that I did not. But let me get Desmos up here. Oh, it is up here. Good. I have it. I wonder if I can do this and just have, why are you not working? Okay, and then have this, oh, not that, sorry you guys. And then have this, and then share this whole thing. And I want to share that. I'm going to try and get this to work, you guys. I don't know if I'm going to be able to. Okay, so I have them side by side, which is kind of what I wanted to do. My calculator on one side and then the presentation on the other here. So, of course, if you have if you're chatting, I can't see it right now, but I can pull it up if we need it. So it says tangent inverse. So if I open up my keyboard here and I go to functions, it has a whole first thing of trig. If you look, it says trig. That's where I want to go in Desmos. It has trig. And then it has sine, sine inverse, cosine, cosine inverse, tangent, tangent inverse. And then it has 3 other ones down here that we will talk about later in, like, when we come back from break later. And then don't worry about the ones over here on this side. Okay, so we're only going to worry about these top 6 right now. And it says tan inverse of 6 divided by 5. So I'm going to do tan inverse, and I want to do 6 divided by 5. And the other thing that this is see, this does not give me an angle. It does. It's 80.87. The problem is I have to go to settings, and this is can I find settings here? Sorry, someone has a chat. No. Well, we'll talk about that, Marco. Oh, here's settings. Okay, there's settings. See how it's in radians? I don't want to be in radians. I want to be in degrees. So once I switch to degrees, see, watch my answer right now. See radians, it's 0.87. I switch to degrees, it's 50.19. I need to be in degrees. We are going to talk about radians, but we're going to learn about radians after the break also. So we're not going to talk about that till we come back from break. So if you're using Desmos default mode is radians. You need to make sure you go to the little screwdriver here, or the little, no, it's not a screwdriver. It's a little wrench up here, and you click on that wrench and change it to degrees if you're doing trig. So this, you have to do that first. Okay. Okay. Yeah, please put them there. So my angle is 50.2 degrees. 50.2 degrees, and that's what x equals for this one. Okay. And now I'm going to do the next one. I think there was a chat up there. Sorry. Let me see what it says. No. So I'm going to go to the next one, and I'm going to erase this. Maybe I'm going to erase this. I'm going to erase this and this. And we're going to say my hypotenuse this time is 7, and my adjacent side is 3. So which one of my functions am I going to use that gives me the hypotenuse and the adjacent? So that's what I want to look for. I want to look for A and H. Well, I have my adjacent side and my hypotenuse side. Well, I can see that right here. I have A and H right here. So that means I'm going to use cosine this side. And I'm still going to do it exactly the same way, though, only I'm going to use cosine. So I have cosine of x is going to equal adjacent over hypotenuse. So that's 3 divided by 7. And I should have moved it a little bit further away. 3 divided by 7. I don't want cosine of x. I want x for angles. So how do I undo my x? Well, I do, just like I did before, I do the inverse of cosine. So that means x is going to I guess I should put should have put approximately equal to on that last one also. So I'm going to go to my functions, and I'm going to go to cosine this time. Cosine inverse of, what is it? 3 divided by 7. And that is approximately equal to 64.6 degrees. 64.6 degrees. And then we're going to look at the last one here. And the last one gives me my hypotenuse, which is 9. And it gives me my side opposite, which is 4. And I'm looking for O and H this time. And that means on this time I'm going to use sine, that which gives me O and H. So it says sine of x is going to equal opposite, which is 4 over 9. And I don't want sine of x, I just want x. So to undo sine, I have to do sine inverse. If I do it to one side of the equal sign, I have to do it to the other. So x is going to be approximately equal to sine inverse of 4 divided by 9. 26.4 degrees. 26.4 degrees. Okay, is there any questions? I do want to say this. I'm going to write this down, and I hope you guys do too. You use sine, cosine, tangent. I'm going to put inverse, right? When finding an angle. So I'm going to use the inverses when I'm looking for an angle. I will always use the inverse when I'm finding an angle. Okay? If I'm just looking for a side, I don't need to use the inverse. But if I'm looking for an angle, I will always use the inverse. Okay? And we are going to talk about that more as we get further down. Okay, so this one just says, well, for the next 3, I'm just going to use the Pythagorean theorem, actually. So it just says, find the missing side length of each right triangle. Give the exact answer and a decimal approximation to the nearest tenth. So I'm going to do A, you guys do B. It needs 2 answers. It needs the exact answer. That's the answer in simplest square root form. And then then I put it in my calculator and find out what it is. What the square root is as a decimal. Sorry, it's not, my calculator's not turning into, oh, there we go. Okay, so I'm just gonna, I like, for me, this is for me personally, you don't have to do it. I'm just gonna draw a little triangle so I know there's my right triangle. So my hypotenuse is 7, and one leg is 4, and I'm gonna call the other one x. So I get x squared plus 4 squared equals 7 squared. So x squared plus 16 equals 49. Subtract 16. That is so, oh, it kind of looks like a 9. So x squared is going to equal 16. 49 minus 16 is 33. Okay. So I'm going to square root it just like we did on our warm-up. So x is going to equal the square root of 33. There's my exact answer. Okay, which is approximately equal to square root 5.74. Oh, to the nearest tenth, 5.7. Sorry, I didn't read that very well. 5.74. There we go. Okay, so now I want you to try B. So maybe turn on the recording. Here we go. So I'm going to just draw my triangle. This was changed just a little bit. The numbers are still the same, but they changed where my numbers are. This one says one leg is 4 and the other leg is 7. So I need to find my hypotenuse there. So I've got x squared is going to equal 7 squared plus 4 squared, which is going to be x squared is going to equal 49 plus 16. So x squared is going to equal, I don't know what it equals, 49 plus 16, 65. Okay, and then I'm going to square root it. So x is going to equal the square root of 65, which I believe is simplified because 10, 11, 12, 13. 5 times 13 is 65, so it doesn't simplify any further than that. And then that is going to be approximately equal to 8.1, rounded to 1 decimal, nearest tenth. Okay? Now, I can use the Pythagorean theorem to find the distance between points also. So if I look at this last problem here on this page, it says find the distance between 1, 5, so 1, negative 1, goodness gracious, negative 1, 5, 1, 2, 3, 4, 5, and 2, 1, 2, negative 2. So they want me to find this distance here. If I can draw a straight line between it, which I can't, obviously. I can use the Pythagorean theorem here also, because if I draw a right triangle, so I drop my line here, and then I drop my line here. I have a right triangle. I just drew a right triangle. I don't know what this length is, but I do know what this length is. This length is 1. I can count 1, 2, 3. Great. And I know what this distance is because I can count here too. 1, 2, 3, 4, 5, 6, 7. And now because I know the lengths of those of the right triangles, I can use the Pythagorean theorem to find the length of the side. So I've got 7 squared plus 3 squared equals x squared. What do I need? Give an exact answer and a decimal answer to the nearest hundredth. So make sure you read your answer because look, they just changed how I want my answer. So let's see, 49 plus 9 equals x squared. So x squared is going to equal 48. So this one actually can be simple. Oh, not 48. Woo, because I subtracted one. I subtracted 1 instead of adding 9. That was really good. Let's try that again. I think that would be 58. Okay. Let's see. 58 divided by 2. Divided by 4. Oh, no. Okay. 29. Okay, so I'm going to square root it. So x is going to equal the square root of 58, which is approximately equal to... Now I can't turn now my phone won't turn, so we'll just use this one. Square root of 58, 7.62. Okay? Questions? Is there any questions? Let me go up here and see if you guys have any questions. Nope. Okay. So we're going to go on to the next thing. And now we're going to go back to trig, I'm pretty sure. Yeah. So this whole, all from now on is all trig. We're just talking about trig, not the Pythagorean theorem. Sometimes we can use the Pythagorean theorem. Sometimes we can't. And if we can, I will. But if I can't, then I'm not going to. I'm just going to use all trig. And if I don't, if there's a situation where it's possible I could use it and I don't, I will tell you why I don't. Okay? So I'm leaving my calculator up because we're going to need it to do some calculations with. So I'm going to leave my calculator here so you can see how I'm using it. Remember, it needs to be in degree mode, not radian mode. So this problem, number 4, says, draw the triangle and find the missing sides and angles. So really quick before I start, I want to make sure, if I can remember how it says, if it says it right. I think on the homework it says solve the triangle. So if it says solve the triangle, that means find all of the sides and all of the angles. So if it says solve the triangle, not just find x or find theta or find whatever's missing if it says solve the triangle, you have to find all the sides and all the angles. So just want to throw that out at you because sometimes it's a different language. What do the angles of a triangle add up to be? Let's start with that question. That's a good question. Does anybody know what the angles of a triangle need to add up to be? Marco, you should know this. We went over this last year. You're the one person in here who can't say my teacher didn't teach me this. Yes, Drew, that is correct. It's 180 degrees. So the angles in a triangle add up to be 180 degrees. So if I know 2 out of my 3 angles, I can find the third one by subtracting from 180. And I do know 2 of the 3 because I know that one is 90 degrees and one is 40 degrees. So in order to find my third angle, I'm going to take 180 minus 90 minus 40, and I should get 50 degrees. So angle A is 50 degrees. And if you needed me to tell you how I did that again, I will be glad to go over that again. But let me know. Everyone okay with 50 degrees? Okay. So now I need to find my 2 other sides. And I can find, let's see, let's label these sides here. So I've got side C is opposite angle C, and side B is opposite angle B. So I need to find both B and C. And I'm going to start with, let's start with finding B. And let's try and get a highlighter and not the eraser. So I'm going to start with finding B. Again, I'm going to use so, ka, toa. Okay, and the one piece of information they give me, oh, and I need to decide which angle to use. That's the other very important issue. I need to decide which, am I going to use the 4? I can't, let me say this first of all, cannot use the 90-degree angle. I've got to use one of the other angles. It's got to either be the 40-degree angle or the 50-degree angle. I'm just going to choose one. It does not matter. Okay, it doesn't matter. So I'm just going to choose the one that they gave me with to start with, which was 40. So I'm going to choose this angle, and I'm going to mark it so I know which angle I'm looking at. So that means that B, if I'm looking at B, B is opposite of 40. So I know I'm looking for one with an A in it. So I'm either looking at sine or tangent because they both have an A in it. And then 6 is adjacent to B. So that means I'm looking for opposite and adjacent, which means I'm looking for TOA, tangent. So that means I have a function that says tangent of 40 equals, tangent equals opposite over adjacent, which equals B over 6. Okay? And I'm just going to make this into a fraction by putting a 1 underneath it. It's a whole number. I'm just putting a 1 underneath it. Okay? I have 2 fractions equaling each other. How do I solve? What do I do? If I have 2 fractions equaling each other, what am I going to do to solve for it? Does anyone know? Let me look in the chat, see if there's anything in there. So if I have one fraction, which is tangent of 40 over 1, equaling my other fraction of b over 6, what I'm going to do is I'm going to cross multiply. So I'm going to take 1 times b and tangent of 40 times 6. So what I get here is b equals 6 tangent of 40. Okay? And then I'm going to put that into my calculator. So I'm going to say 6 tangent of 40. And I get my answer, which says approximately 5.03. Okay, and now I need to find, now I have 2 of my 3 sides. And I want to say I could use the Pythagorean theorem. But I'm not going to, and I'm going to tell you why. Okay? So in order to find b, I rounded, right? I rounded this. This is rounded. So it's already not quite the right answer. And then once I do the Pythagorean theorem, I'm going to square it, and I'm going to square root it, and I'm going to end up rounding and rounding and rounding. So my answer might, by the time I'm done with it, by the time I'm done rounding a couple times again, so I rounded once and then another at least twice probably. In some cases, at least twice. This case, I wouldn't have to round more than one more time. But my answer might be too far off to be correct. Okay? So sometimes using the Pythagorean theorem, unless my answers are exact, so like if that would have came out as exactly 5, I would have definitely used Pythagorean theorem because it's easier. But since it didn't and I had to round it, I'm going to use my trig functions again because I only rounded once and that was when I got my answer. So I'm going to find c this time using my trig functions. C is here, and that's my hypotenuse. So I want to find something using my hypotenuse. Well, my hypotenuse is either sine or cosine. Okay? And I still have the adjacent side. So the adjacent and the hypotenuse is cosine. So I have cosine of 40. Yeah, I kept the same angle, so I didn't have to change a lot. Cosine of 40 equals adjacent, which is 6, over hypotenuse, which is c. Okay, I'm going to do the same thing. I have a fraction equaling a fraction, so I'm going to cross multiply. Okay, so I end up getting c cosine of 40 equals 6. Well, c still is not by itself, so what am I going to have to do to get it by itself now? Anybody? What do I have to do to solve for c now? Well, what I'm going to do is I'm going to divide by, cosine of 40 is just some number. If I type it into the calculator, it's just going to give me a number. So it's just some number. So I'm just going to divide by the cosine of 40 on both sides. Ooh, cosine, dang. Cosine of 40. So that means c equals 6 divided by the cosine of 40, which is approximately going to be equal to, and if I put it into my calculator, this time I'm going to go 6 divided by function cosine of 40. And I should get 7.883. Okay, questions? Oh, 7.83. Okay. Okay. So the next 3 questions just say solve. Basically, I'm solving for the variable wherever that may be. I'm going to solve for it. Okay. So in the first one, it looks like I'm solving for an angle. So what do I have? I have the side opposite, and I have my hypotenuse. So if I'm looking at SOHCAHTOA, I have the side opposite, which means it's either sine or tangent, and then I have the hypotenuse, so that's going to be sine. So sine of theta equals opposite, which is 25, divided by hypotenuse, which is 31. And in order to, I don't want theta, I don't want sine of theta, I just want theta. So I'm going to do, how do I get rid of sine? I do sine inverse. And if I do it to one side, I have to do it to the other side. So that means theta is approximately going to be worth, what is it? Sine of theta? Sine inverse of theta of 25 divided by 31. So 53.75 degrees. Don't forget, these are angles. Angles are measured in degrees, and we need to label those. Okay? So, okay. And then for my next problem, I'm just finding x, which is the hypotenuse. So I'm looking for the hypotenuse. So if I'm looking for the hypotenuse, and I have, let's see what angle I have. I have this angle here. So I have the hypotenuse, and I have the side opposite. So opposite and hypotenuse is sine again. So I have sine of 62 equals 24 over x. Make a fraction out of the 2, cross multiply, so I get x sine of 62 equals 24, divide by sine of 62, so x is approximately equal to I don't know why I'm doing it there. 24 divided by sine of 62. Oops. Sorry, I got a little crazy there. Let's try that again. 24 divided by sine of 62. Okay, there we go. So it's approximately equal to 27.12. Oh, I don't think it's 1.2. I think it's 1.8. 1.8. There we go. Okay, I want you guys to do number 7. Please go. Okay, so I'm looking for this angle right here, x. And I have the hypotenuse and the side opposite. So that's sine again. So sine of x is going to be equal to opposite 14 over 32. I don't want sine. I just want x. So I'm going to do sine inverse. And whatever I do to one side, I do to the other side. So I've got x is approximately equal to sine inverse of 14 divided by 32. So 25.94 degrees. Okay, questions? Everyone's being really quiet today. Is it just because it's Monday? Sorry, you guys. He's trying trying to find a Christmas present for his grandma, and he doesn't know what to get her. So this one says, now the last part that we're going to do, I think there's like 4 more problems that we're going to go over. And I think we're doing okay on time, is story problems. So when I'm doing a story problem, I'm always going to draw a picture of it, because once I draw a picture of it, I know it's okay, first of all, I know this is a right triangle trig problem, so I know my picture is going to be a right triangle. Somehow in there's going to be a right triangle. Okay, so it shouldn't be that hard for me to draw a right triangle. And so I know that's going to happen. So I'm going to draw at least one right triangle, if not more, to try and figure this out. So I know my drawing skills don't have to be like super duper great, because they're not in the first place. I can draw a triangle, sorta, as you saw. And then I'm going to label it, and I'm going to try and answer the question. Okay, so that's what we have to do. Sketch a picture of the situation and solve. So Sarah has a rectangular yard. So she has a rectangular yard. So I have to draw a rectangle measuring 18 feet by 36 feet, okay? She's hanging lights along both diagonals for a party. So she's hanging lights along this diagonal and this diagonal. They're the same length. I just want to point out, same length. How long do the strings of lights need to be round to the nearest length? Okay, so she's just hanging lights on the diagonal. That's it. So I need to find out what this length is. And then I'm going to multiply it by 2 because there's 2 of them. Okay, so I think I can do the Pythagorean theorem on this one. So I've got x squared is going to equal 36 squared plus 18 squared. Oof. X squared is going to be equal to 36 times 36. I don't know. Just want to make sure it's right. 1296 plus 324. So x squared is going to be equal to plus 1620. Okay. Still not doing that for me. Okay, so I need the square root of 1620. So it says round to the nearest foot. The nearest foot, square root. So x is approximately going to be equal to 40 feet. So to answer the question, the strings of lights, Lights, need to be 80 feet long. Okay? Story problems are usually answered in the form of a sentence. Why does it need to be 80? Because there's 2 of them. 40 is one diagonal, and then there's 2 diagonals of the exact same length. So it should be 40 plus 40 is 80 feet long. Okay? Pause for a second. Any questions so far? You guys are really quiet today. Okay. So here we go. Johnny is standing 22 feet from a tree and measures the angle from the ground to the top of the tree to be 59 degrees. How tall is the tree? Okay, so we have a tree and we have Johnny standing over here somewhere. Okay, and he's 22 feet from the tree, and this angle from the top of the tree to the ground is 59 degrees, and he wants to know how tall the tree is. So again, we're going to use SOHCAHTOA. So what 2 sides do I have? I have the side opposite and the side adjacent to that angle. So that would be opposite and adjacent tangent. So tangent of 59 is going to equal x over 22. Cross multiply. Okay, and I get, what do I get? X equals 22 tangent of 59. So x is approximately equal to, what is 22 tangent of 59. 30, does it say how tall is the tree? Okay, 36.6 feet tall, right? So really I should write a sentence saying the tree is 36.6 feet tall. Okay. But don't forget to label and answer the question. All right, so the next question says, what does the next question say? Lying on the ground, Samantha is looking at her kite in the sky. The angle of elevation is 71 degrees. If there is 1,500 feet of kite string and it is taut, how high in the sky is the kite? So here's Samantha, here's my kite string. Wow. We've got 1,500 feet of kite string. So when we fly a kite, the kite is at a diagonal from us. This angle of elevation is in the upward motion. That's elevation is going up. And that is, what did it say it was? 71 degrees. And they want to know how high in the sky the kite is. So I have side opposite, and I have the hypotenuse. Well, opposite and hypotenuse is sine, okay. So I have sine of 71 equals x over 1,500 feet. Cross multiply, and I get x equals 1,500 sine of 71, which is approximately going to be equal to sine 71. 1,418.3 feet in the air. It's pretty high. Okay, questions? Okay. Last question says, a commercial airline pilot is flying at an altitude of 6.5 miles. To make a gentle descent for landing, the pilot begins descending towards the airport when he is 186 miles away when measured on the ground. What angle will the plane's path make with the runway? Okay, so he is 6.5 miles into the air. And on this one, I have to be careful. This is in miles, and this is in miles, so I'm okay. 186 miles away. And it wants to know the path the plane will make with the runway. So it wants to know that angle, and I'm just going to call it x. So what does it give me? It gives me the opposite, and it gives me the adjacent. So it gives me opposite and adjacent. And if I look up here, opposite and adjacent is TOA. So tangent of x is going to equal 6.5 over 186. So tan inverse x is approximately going to be equal to, parenthesis, tan inverse 6.5 divided by 186. 2 degrees. That's it. Okay. So you have just over 10 minutes to work on your delta math and ask any questions that you want. Let me